Hi there, and welcome back to MA211. Today we're talking about Heaviside functions. The other name for a Heaviside function is a unit step function. And that's where it gets its symbol, which is a script U. And you can read all about Heaviside functions in the book. I just want to practice a little bit making functions that we want to make out of Heaviside functions. So the first exercise we'll do is you're given the graph of a function. Sorry about that. And you would like to describe that function in terms of Heaviside functions. Now, we know that a Heaviside function satisfies this property that u of t is 0 if t is less than 0 and 1 if t is bigger than 0. This function looks just like that, but it's shifted to the right. So this function is a shifted version of the Heaviside function. This function is u evaluated at t minus 1. If you check u evaluated at t minus 1, anytime t is less than 1, then t minus 1 will be negative, and so plugging that into the Heaviside function will give you 0. So this is 0 if t is less than 1, and if you put in something bigger than 1, then t minus 1 is positive, so you'll get 1. And so you do get this function out of u of t minus 1. Now I want to try something different. What if you want to describe a function that's like this? It's 0 for a while, and then at time 1 it turns sort of on. It becomes 1, and then at time 3 it sort of turns off, and it becomes 0 again. Well, the way you do this jump, you say, okay, well look, this looks like u at t minus 1, right? If you just wrote down u at t minus 1, you'd get the behavior of being 0 up until time 1 and being 1 after time 1, but your function would stay like this. It would take on value 1 forever after time 1. And that's not what we want. What we want is a second jump here, and that's going to correspond to a second Heaviside function. So what we'll do is we'll subtract off u t minus 3. Okay? And now what this will do for us is the following. If t is less than 1, then u evaluated at t minus 1 will be 0, and u evaluated at t minus 3, that'll also be 0, and so you'll get 0 minus 0 equals 0, right? So u t minus 1 minus u t minus 3 equals 0 for times less than 1. Okay. If your time is just a little bit bigger than 1, say it's bigger than 1 but less than 3, then u of t minus 1 is 1 and u of t minus 3 is 0. So u of t minus 1 minus u t minus 3 is 1. And for times bigger than 3, then u of t minus 1 is 1, u of t minus 3 is 1. So u of t minus 1 minus u of t minus 3, that's going to be back to 0. So you can check, and we just saw that, yeah, the function u evaluated at t minus 1 minus u evaluated at t minus 3, that really does have a graph that's that thing. Alright, so let's try something different here. This time we want a function that is 0 up until time 1. At time 1 we'd like it to take on value 2 instead of 1. and then at time 3 we'd like it to take on value -1. And now there are several ways you could do this. I'm going to show you the way that sort of makes it easiest to think about. So what I want to do is I'll take a look at this first jump and I'll say, well, this looks like 2 times a Heaviside function shifted by 1. So this is 2 times u t minus 1. If I just had the function 2 times u t minus 1, I would get this first behavior. I'd get 0 up until time 1, and I'd have 2 after time 1. Okay? Now what I want is my function to stop being 2 at time 3. So what I'll do is I'll subtract off 2 times u t minus 3. Now if I left this function, then my graph would look like this. It would be 0, it would be 2, and then at time 3 we'd have 0 again, and that's not what I want. So what I've done is I've turned on 2 at time 1 through my Heaviside function, and I've turned it off at time 3 through another Heaviside function, and now what I want to do is turn on the function -1. So I'll write plus -1 times u evaluated at t minus 3. And what that's doing is turning this guy on. Now I realize there are other ways you can think about this. You could say, well, I want to take 2 and subtract off 3 to get down to -1, so I'll just do that, and that's fine. What I'm showing you, turning these functions on and off, will make it a little bit easier for you later on down the road, I think. So now what you can do is say, well, let's go ahead and factor these two terms, right? I can group my u t minus 3 things. I'll call this 2 times u t minus 1 minus 3 u t minus 3. Alright, now let's write something that describes this function, again in terms of Heaviside functions. This graph right here, this is the graph of, let's see, this is t between 0 and 3, and this is -t plus 6 between 0 and 5. And let's just say that we want it to be 0 after that. Okay? So what am I going to do? I want to turn on the function t at time 1. So I'll write t times Heaviside function shifted by 1. That would give us this first behavior of t turning on at time 1. Now I'm going to turn off the t at time 3. So I'll write minus t evaluated at u t minus 3. And now I'll turn on the function -t plus 6. So I'll write plus -t plus 6. I want it to turn on at time 3. And now I want to turn off the function -t plus 6 at time 5. Right? So this one turns my function on. This one kills the function. This one turns on a new function, and this one turns it off. Okay? And of course we can go ahead and simplify this. It's probably nice to simplify things because we are going to want to Laplace transform them later on. So sort of the simpler algebraically they are, the better. So this will be t ut minus 1 minus 2t minus 6 ut minus 3, and then plus t minus 6 times u t minus 5. Okay? Alright. Let's see. We're going to start using Heaviside functions for modeling in a little bit here. This is sort of a warm-up problem for that. We have a problem where salt is flowing into a tank at a rate of 3 pounds per minute. After 10 minutes, the flow suddenly changes to 6 pounds per minute. And after 20 minutes, the flow stops completely. So we want to give a function describing the flow of salt into the tank in terms of Heaviside functions. So let's just graph that quickly. What is our flow looking like? So it's 3 pounds per minute up until time 10, when it suddenly takes on 6 pounds per minute. So it's at 3, and then it's at 6. It changes at time 10. Alright, and after 20 minutes the flow stops completely. So at time 20 we have no flow, and here we are. So this is our flow function. We can describe this in terms of Heaviside functions, no problem, right? So this guy is 3, and it turned on at time 0, so I'll just call it 3 times u evaluate at time t minus 0. You can also just call that 3, it's fine. It all depends on whether you think the inflow started at time negative infinity or did it start at time 0, and it doesn't matter which you do for these initial value problems, it doesn't matter. So I would take either a 3 times Heaviside function or just 3 for this first term. Now at time 10 I want to turn off my 3, so I'll say minus 3 times u t minus 10. And at time 10 I want to turn on the function 6, so plus 6u t minus 10. At time 20 I want to turn off my 6, so minus 6u t minus 20, and then that's it. And if you wanted to simplify this, you could call it 3 times, or 3 plus 3 u t minus 10 minus 6 u t minus 20. Okay. Now one more. We have force applied to a spring mass system, and it's given this way. It's t if times it's t between 0 and 3, it's 3 between 3 and 5, it's negative 2t plus 13 between 5 and 6, and it's 1 otherwise. So let's just go ahead, let's not bother drawing a graph this time, let's just write it down in terms of Heaviside functions. Notice that this function, again, it's not defined for time less than 0. So its very first term, I can write it as t, that's fine. Or I can write it as t times a Heaviside function if I think it was 0 before time 0. It doesn't matter either way. We're only interested in positive times, so it doesn't matter. Let's see. So I'll write it as t, that's my first function. At time 3 I want to turn the t off, so minus t u t minus 3. And at time 3 I want to turn on the function 3, so plus 3 u t minus 3. At time 5 I want to turn off the 3. And at time 5 I want to turn on a new function, negative 2t plus 13 u t minus 5. And at time 6 I want to turn off that function, minus negative 2t plus 13 u t minus 5. And then I want to turn on just 1. And that's it. And that's all there is to building functions out of Heaviside functions.